Hey everyone! In this video, I want to talk about how to scale the front end in Cherwell Service Management. And by front end, specifically what I mean is the browser client, the portal, and the app server. So the three web-based components that you might want to scale out that allow user interactivity. I'm also joined here by my cat. He's probably out of frame, but if you hear him meowing in the background, that's what that is. My cat is sitting on my desk, diligently watching this presentation. So before we get into it, I do want to quickly mention Synapse Software and what we do. We're a software development shop and consultancy built on empowering you to be the best version of yourself and enabling companies to reach their full potential by achieving successful digital transformations. We use Cherwell Service Management as our no-code platform of choice to accelerate development. You can learn more about us at our website, synapsesoftware.com, also linked in the description below, or you can send me an email at the email address listed below to find out what we can do for your company specifically. So to start out with, I want to show this slide, which I used in a video a week or so ago when I talked about scaling out Service Host. This is the exact same picture, and we're going to look at a different slice of the overall architecture. So here I basically charted out the basic architecture of Cherwell Service Management. So if you just run the installer, this is what you'll get on your systems. So in this video, we're going to talk specifically about these components. So portal, browser client, app server, and the backend data services that they talk to. So we'll also have to consider Redis because we're talking about scaling out. So in the previous videos, we haven't had to talk about Redis because you can run CSM by itself perfectly, fully functionally without Redis. However, Redis is critical to having a successful load balanced environment or scaled out front end environment. So before we go any further, I'm going to do a quick demo on how to configure server farm. That is Redis, but in Cherwell it's called server farm mode. So I'm going to switch over to Cherwell Server Manager. Let me drag this over to the screen that you can actually see. So in order to configure Redis, we'll go down just below this divider and you'll see it says server farm mode is off. This is running on my laptop. It's a single machine, standalone environment. I'm not using Redis. But if I wanted to make it part of a server farm or scale out the front end components, I would need to enable server farm. So I'm going to click this configure button. I'm going to say enable server farm mode. And then the important parts here is you specify a host that is running Redis. So if you want to install Redis on this current machine, that's fine. That doesn't really achieve high availability. You probably want to install Redis on its own machine. And I'll do a video in the coming weeks specifically on how to install Redis on another machine so that you can use it with a CSM environment. But for this video, I'll assume you already have Redis installed somewhere and you just want to connect your CSM system to your existing Redis server or Redis cluster. So what this looks like is basically you enter the host name for that Redis server or Redis cluster and the port. If you're using a Redis cluster, you would actually enter the host name for one of the nodes, click add, then the second node, click add, third node, click add, however many nodes you have. If there's a password, you would enter it here, and then you just click OK. I'm not going to enable server farm mode just because I know I'll forget that I've checked that box if I leave it saved that way, and then I'll be wondering why things aren't working. So I'm gonna leave that unchecked. So let's go back to the slides. So once you have server farm mode enabled, Oh, and a note on that, that needs to be set up on every single machine that needs to connect to Redis. So in this slide here, you need to configure it on this machine, this machine, this machine. If they're all running on the same server, you're good. You just configure it on that one server, and you don't need to configure it anywhere else. But we're talking about scaling out. So you will have to add this to multiple machines. You will have to configure this on multiple machines. So let's go to the next slide. So for the purposes of this talk, we're going to talk about browser client specifically. The instructions are basically the same for browser client and portal and for the app server as well. The reason I want to use browser client is because there are some nuances specifically with the browser client and portal with the way that one-steps work. If you've been using Cherwell for a while, you may have heard the term SignalR or WebSockets. That's kind of what leads to this additional complexity with the browser client and portal. So we'll talk about an architecture that's something like this. Basically, we'll have four front ends, all talking to, and this is very important, they all need to be talking to the same Redis, the same SQL Server, and the same RabbitMQ or Cherwell MQS, as the arrows indicate. So each machine has 3 arrows, one pointing to each of those 3 backend services in the data layer. So in order to make this actually work, you'll need to add a load balancer in front of all of these front ends. And this is important. You could do something super simple like DNS round robin load balancing, where you have one DNS name and it just lists, in this case, 4 front ends as potential IP addresses for that DNS name to resolve to. But it's really recommended to use an actual load balancer. Things will just work a lot more smoothly. And for load balancers, you have a lot of different options. If you're using AWS for your hosting, you can use an ALB, an application load balancer. That's a well-tested use case with Cherwell. You can also use Azure App Gateway if you're using Microsoft's cloud. That's also known to work with Cherwell. You can use Nginx or something built on top of Nginx. That's a popular option for a very lightweight, free, Nginx is open source, option for building a load balancer. I've used Nginx as a load balancer for some of my applications. I haven't used it with Cherwell, but the important part there is definitely you want to make sure that you allow WebSockets through Nginx. I think the same applies for Azure App Gateway. I think that's a setting you have to enable. ALB, I believe, enables it by default. And then, of course, you can actually go out and buy an appliance to do load balancing, like an F5. I have no personal experience with F5, but I know that some people are using it for Cherwell, and there is some configuration involved. I don't know exactly what that looks like, but I do know that that's an option. Things to watch out for. I've already mentioned WebSockets. So you do need to make sure that WebSockets are allowed through the load balancer and that they are handled end-to-end. You also have to watch out for something that might be called sticky sessions. You might want to make use of this. Basically, the idea is that a single user will always talk to the same front end sitting behind the load balancer all the time. If you don't use sticky sessions, the load balancer will take each individual request and send it to whatever front end it thinks needs to service that request at that time. So you have some different options there. Yeah, I think that's pretty much it in the gotcha column. Now you might be wondering why I don't have a demo of load balancing here. The reason is that I didn't want to make this video super long, doing a demo of all of these different options or even a single option. But if there's a particular technology that you want me to do a demo of, leave a comment below and I'll do a demo of, say, using an application load balancer in AWS with Cherwell behind it. So let's talk about a slightly more complex scenario that is actually a fairly common setup. So a lot of people don't necessarily want to scale out the entire Cherwell application, right? Because typically you have a lot more portal users than you have browser client users, for instance, or you might have a lot more rich client users than web users. So it doesn't necessarily make sense to scale out the entire thing across, say 4 machines, install the entire thing on all 4 machines. So you might want to do, say, 2 machines for portal, 2 machines for browser client, 2 machines for app server, as in the diagram here. Or you might want to do 4 or 5 machines for portal, and then 1 or 2 machines for browser client, and 1 or 2 for the app server. It's up to you, and it really depends on the way you use Cherwell and your particular load on your network. But just to make things easier, in this diagram I have 2 browser clients, 2 portals, and 2 app servers. Of course, when you install Cherwell, all the components install, but in this case, we're just pretending that these are the only components that I have enabled in IIS or web accessible. So for each segment, you would typically have a load balancer for each component. So you'd have a load balancer for the browser client, load balancer for the portal. And this is not an uncommon way to do things. It does mean that you have a different DNS name for browser client than you do for portal. But again, this is not an uncommon way to do things, because let's be honest, most people use bookmarks or go to a link from an app portal page that's just a list of links, kind of a directory sort of thing. So the fact that you have 2 different URLs for 2 different pieces of functionality, it's not that big a deal. But if you wanted to go that extra step and have 1 domain name, but still have this sort of network, so you can scale out the browser client, the portal, and the app server independently, you could introduce a piece of technology called an API gateway. Both AWS and Azure have this functionality. I'm not sure what you would do on-prem. You might be able to do it with Nginx. That would probably work. It's basically a reverse proxy is what it is, where certain paths get reverse proxy to different pieces of your environment. So in this case, you'd have the API gateway that would have 1 domain name, let's say cherwell.synapsesoftware.com or something like that. The API gateway would route requests to /Cherwell client over to the browser client part of the network, /portal over to the portal part of the network, /Cherwell app server to the app server portion of the network. But it would all look externally like 1 cohesive service. So in my opinion, I think that's pretty cool. This is probably how I would set up my network, just to make it, as easy as possible, as seamless as possible, make it look like a cohesive whole, as opposed to disparate services that are all kind of part of the same overall environment, overall network. If this is something you're interested in doing, go ahead and drop a comment below or shoot me an email, and I definitely love to help you set something like this up. Yeah, so with that, that's pretty much the end of the video. If you liked this, go ahead and click that thumbs up button. Definitely subscribe to the channel. I've got some cool videos coming up, even some that have been requested by you guys. So if there's a topic that you want to hear, definitely drop a comment below, shoot me an email. Those are the best ways to get a hold of me, and let me know what you want to see in the coming weeks. Otherwise, I've got a long list of topics that I'll just keep turning through, and you can subscribe to the channel and click that notification bell to get notified when those videos get released. Thanks for watching, and have a great week.